Okay, so question here then is we've got all these nice tools that we can use right inside a spreadsheet, and you know, why do we even care though about this modeling framework of discrete event system simulation? And why would we care about enabling ourselves to study even more complicated systems or complex systems that might be difficult to capture in a spreadsheet and force us to use one of these specialized programs like Arena, FlexSim, or Simio, or many others? And so if you think about it, the reason is that real operations are complex and not easily captured in a spreadsheet, and often involve problems that are well modeled by discrete event system simulations. And so let's take, for example, this fast food restaurant that is depicted here. This is one way in which they have ordered their drive-through. They've got these two places where you can order here and order here. Then you actually pick up the order over there. So it's sort of fascinating here that you're waiting, two people are ordering, but the person who's ordering in front is actually going to get in the way of the person behind them. But this fast food chain ended up kind of recognizing that it was beneficial for them that they could make their orders so quickly that it was beneficial for them to be able to try to gather the orders as quickly as possible. Because really the person back here, it's sort of unfortunate that when the first person orders and then is sitting there waiting to get to the window, that if the fast food restaurant would just know who the second person was and what their order was, then they might be able to get a jump on it because they're probably going to be done with the first person's order before the first person gets up there to pick up the order. So rather than having a bunch of idle time inside the restaurant, it'd be nice to have another order waiting. So it's this interesting balance where you're trying to make use of this delay that the customers have to wait through. But this is a delay that is sort of unfortunate because it's not a delay because they're waiting for their own food to be prepared. It's a delay because they're not even able to make the order until this other person gets out of the way. And they've experimented with different ways to deal with that. So here's another topology, same restaurant, same chain, but a very different way to set it up. So now you've actually got these multiple windows in parallel. Now each window only has one place to order. So they didn't do the two ordering. It's not like they have four places to order here, but you now have these orders that go in parallel with each other. Now, sometimes you can't build this because it's going to take up too much parking lot space, but there might be other reasons why sometimes this topology works better than this one. And you might notice that some fast food restaurants that started with this, and let's say they've actually got windows that are right on the side of the building, have found out that this actually hasn't improved their operations that much, and they've ended up concreting up that second window and gone back to a one window scenario. So there's clearly some difficult decisions that have to be made about how to make these orders work. And they all reflect a delicate balance between how quickly orders can be made, how quickly orders can be arrive, and how quickly you can manage to get the order out of the person. And so it's not clear what is the right decision to make, but it is very easy to simulate all these things and crank these knobs up and down and run experiments. Another sort of example that you've probably seen a lot of is the order ahead case. And so, if you go to coffee chains like this one, you once upon a time, and you still do see these giant lines. You might be familiar with this if you wanted a coffee between classes and decided that coffee was more important than showing up for class. So I will not accept this as an excuse to showing up in class late, by the way. Although I myself, even as an instructor, have shown up late for class. Not necessarily because I was in line waiting to order, but because I was in line waiting to get my order, and I was now held hostage by the fact that I had already paid for something that was taking 15 minutes to prepare. So yeah, there's a lot of interesting operational challenges there. But this order ahead with mobile order and pay has really changed the way in which restaurants like this one, like Starbucks, like McDonald's, have started to do their operations because they realized there was a resource that they couldn't. They realized that their service times had gotten so small that they really couldn't reduce their service times any further, and they needed an alternative way to improve operations. And they realized that every customer ends up, especially in the case of standalone stores where people arrive by vehicle, every customer ends up spending a lot of time coming to the store, and that is time that Starbucks could use even though before, like that's not technically time that they own because the customer's not even at the store, but the customer's committed to driving to the store, and so that's time that Starbucks could be using, and that is an activity time. It's not a delay, right? So the customer spends the activity of taking the time to drive to Starbucks. Now, what if there was a way for them to hide any possible delays by using that activity? And that's what the order ahead does. By ordering ahead, what it tells Starbucks is, whereas before, the customer would once a customer gives an order, they have to wait on that order to be served. And then if there are any orders ahead of them, immediately that customer starts to wait. Now, what ordering ahead does is it shifts things around so that now when you order, you have this buffer of this activity time of how long it takes you to get to the store. And that's a time that a manager of the store can realize that it gives them a buffer so that that even though your drink might be waiting to be prepared, you don't view that as a delay, and because it's taking place in parallel to another activity you had to do anyway. You already had to drive there, and so you're driving there while it's being made, and so that what would have normally been perceived as a delay is now just part of something that's going on during another activity. It's like taking a Gantt chart and restructuring the Gantt chart to make things more efficient. That's sort of what they're doing here. And it's kind of interesting if you think about it. This idea of ordering ahead is an old one. It's one that pizza places did. And now back in those times, pizza places, the only way they could even make any business was to order ahead because it took so long to make a pizza. If somebody wanted a pizza for takeout, they wouldn't just show up because they're not going to want to sit there for the time it takes to make the pizza, just waiting for the pizza. They may as well, have come there and decide to eat the pizza there if they're going to wait that long. So the pizza places realized that they could, if people just ordered ahead, then the time it takes for them to travel would time that you could bake the pizza and you could greatly reduce the delays. And so this was a way in which the pizza places dealt with with service times that could not be made any shorter. And so in the case of coffee places, they've now reached a similar time where now the service times have gotten so short, and fast food places as well, they can make the food so quickly that their operations don't benefit by making any adjustments to their services. The only way they can improve their operations is by working on the ordering side of things. And so what these places are doing is they're telling people if you just order ahead, then the activity of driving to the place is time in which we can end up reducing the delay you'll have to wait. Now, we play these games even on our own heads. So like if you're, let's say, sometimes I would have to stop at the grocery store on my way home, but I might want to pick up a pizza. Now, I could go to the grocery store first and then order my pizza and go to the pizza place and then wait at that pizza place. Now, you can imagine other things too. I could order the pizza first and go and pick up the pizza and then wait for the pizza and then go to the grocery store and let the pizza sit and get cold in the car. Now, neither of those are ideal, so ideally what I should do is I should order the pizza from a pizza place near home, go to a grocery store, and then do my quick grocery shopping, and then go and stop at the pizza place after that. And the time that I had to spend anyway at the grocery store was time that the pizza had to bake without forcing me to wait on the pizza. So it's a way of preventing conditional delays. So it's this weird thing where, if you think about it, the reason we have delays are because activity times are often very, very short for most people, but they accumulate into a long time so that any individual has to wait for the activity times for a bunch of other people. Well, now if you can take people's individual activity times and make them longer, then there's ways to reshuffle them so that a lot of activities can happen in parallel, and that ends up giving you time so that no one actually ends up having to wait. So the key thing for like a Starbucks or a McDonald's is that the service times have to be extremely short, or the activity times of arriving at the Starbucks, the travel times have to be sufficiently long. And those two things, if you can't make the service times any shorter, you have to try to make the travel times, or the time, after the order before the delay, to be very long. And so but then exactly how you get, whether you should be doing that in this, version or this version, or whether you have to depend on phones, all of that is going to depend on the distributions of, the products, how often people arrive, all of these things, all of these complicated questions about how to structure your operations are not easy to sort of solve for in the back of an envelope with a little bit of mathematics. And that's why we can use these discrete event system simulations to try all these different scenarios and see which one's better for a particular system, which may not be a general result, but that's part of the beauty of it, is that you can customize these simulations for a McDonald's, for a Starbucks, for a pizza joint, and you might end up finding different results, but those results will be catered to those distributions that come from those different systems, which makes them very useful in an applied sense. All right, so just sort of summing up, we could use simple mathematical analysis to get kind of a general feel about systems across the board, but they're kind of insufficient for these real-world systems and these applied cases for a number of different reasons. So we end up resorting to simulation to sort of figure out these kind of non-trivial results. So these simulations that we do in the very complicated simulations are very cumbersome to manage by hand in a spreadsheet, although it might be possible. But if we want to make any changes later on, we're probably going to have to write a whole new spreadsheet. And so that's why we end up using packages like Arena, FlexSim, Simio, AnyLogic, etc. They have a nice, easy graphical management that allows us to quickly reconfigure systems. They allow us to use components like carts and conveyor belts and finite length queues, as opposed to try to implement them in kind of this functional programming of the spreadsheet. So they really are customized for common things that we see in these systems, and they have common performance measures, like how long do customers wait. We don't have to write that all ourselves. So I mentioned that that's kind of why DES is important, and so in lecture C2 we'll kind of mention some of the other agent-based frameworks and system dynamics modeling frameworks. You'll also see a little bit of this in your lab 3 that'll go over a little bit of these different frameworks and how these might be used. But the focus of this class is on these process-centric models, these discrete event system simulation models. And that's all I've got for you now, so I still have a question or two for you. So head back to Canvas, answer that question, and then you're done with lecture C2.